Hi, this is Shannon Seaver. Today we are beginning the three-part series of equivalent statements in section 3.5 of our book, and we'll get started. Our agenda for today is to use a truth table to show that statements are equivalent. Equivalent compound statements. They are made up of the same simple statements and have the same corresponding truth values for all truth-false combinations of these simple statements. Notice that this is the symbol used to indicate equivalence. Show that P or not Q and if not P, then not Q are equivalent. So we're going to make up a truth table with all of these things in it, and we're going to look to see if they're equivalent or not. So let's start off with this part. And we don't have a not Q in our table here, so I'm going to go ahead and fill that in. And we have an OR statement. So with an OR statement, we are looking for two falses in the P and in the not Q. So we have two falses right here. I think everything else will be a true. Now I want to look at this statement. I'm going to go ahead and rewrite my not P and not Q here because we have an if-then statement. So I want to make sure that I have them in the right order. So an if-then statement, we are looking for first a true, then a false to make a false. And we have that right here. So that'll be a false. Everything else is a true. So note that we have two columns right here that are exactly the same. They both have true, 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 false, false, true, and true. So because of that, we can actually say that these two statements are equivalent. And I could write it like this: P or not Q, and then use the three dashed line to say equivalence is equivalent to P, if P, not P, then not Q. And we can say that because their outcomes are exactly the same. Use the result from part A to write a statement that is equivalent to the bill receives majority approval or the bill does not become a law. Notice that that is in the form of P or not Q, because we could say the bill receives majority approval is P. The bill does not, so it's a not, become law is not Q. So we can write this same statement in this form. I could say if the bill doesn't receive, pardon my writing, majority approval, then the bill does not become a law. Or doesn't, we can use that too. So notice how this statement right here means the exact same thing as the italicized statement above. Now, I want you to take a minute to try this on your own. Pause the video and then try it and check your work. So if we did the table, we found that P or Q is equivalent to not, if not Q, then P. And if we rewrite this sentence here in italics, we have, if I don't lose my scholarship, then I attend my classes. Now, we want to show that this over here is equivalent to not P. So we're going to start off with just P. We only need a true and a false for this because we only have one statement. And we're going to work from inside out. So I'm going to pick the most inner part right here first. We're going to do not P. That becomes false, then true. Then I'm going to work my way out of that. So it'll be not P. This becomes true, then false. And then I'll work my way out of that one. This will become false, then true. And we want to show that that is equivalent to not P. So I'm going to go ahead and just rewrite not P right here, even though I really didn't need to. And notice that, yes, indeed, they are both false, true as an outcome. So you might have something like this in your bookwork where you have to reverse it several times, and you want to show that it's equivalent to another part that's just reversed once. Now, let's look at equivalence and truth tables with several statements. We have Miguel is blushing or sunburned. I'm going to write that in symbolic form. I'm going to say Miguel is blushing is P, or sunburned is Q. So that is our first statement on this. And I want to see if this statement is equivalent to all the following statements. If Miguel is blushing, so that would be P, and then if then, he is not sunburned, so it would be not Q. On B, Miguel is sunburned, so that would be Q, or blushing is P. If Miguel is not blushing, so it would be not P, if then, he is sunburned, be Q. And if Miguel is not sunburned, not Q, then he is blushing, P. So after we've converted everything into their symbolic form, what we really need to do is put all of these forms into a table and compare to see if they have the exact same outcome. So I'm going to start off with P and Q. We have true, true, false, false. Then we have true, false, true, false. So now I'm going to look at this very first statement right here, P or Q. Well, we are looking for two falses, and we have them on the bottom row, so this will become a false, and everything else will be true. So any of these outcomes that have the same outcome as P or Q, they're equivalent. We are looking for the statement that is not equivalent. Okay? So the next one, let's do P or not Q. We need to get a not Q here so that we can do that. False, true, false, true. So if we have a P, if P, then not Q, we are looking at this column and this column. And we need first a true and then a false. And we have that in the top statement right there. So I'm going to make this a false, and everything else will be true. Now notice that these two columns here, P or Q, and P, if P, then not Q, are not equivalent. So already I can say that A is not equivalent to the original statement. Let's test the rest of them. We have Q or P. Now we're looking for two falses again, and you know what? That is exactly the same thing as P or Q. Order doesn't matter in that case, so that is definitely equivalent to the original statement. Let's try not P, then Q. So we need a not. So I'm going to put false, false, true, true. And I need to look at Q, and I'm going to squeeze that in right here so that I can get it. The order matters in this. So we'll have not P or Q in the outcome. So Q was true, false, true, false. Remember, we are looking for first a true and then a false. So this will be false, and everything else will be true. Now notice, that is exactly the same as the original outcome. So that is equivalent to the original statement. So the last one we want to look at is not, if not Q, then P. So we're going to look at not Q again, false, true, false, true, and I'm going to squeeze P in here again. We have true then false here, so I can write this as a false there, and that is also equivalent to the very beginning. So the only statement that is not equivalent to the original statement is A. So what is an equivalent statement? An equivalent statement is where two statements that have the exact same outcome on a truth table. So if you're asked if it's an equivalent statement, you really need to show it on a truth table. Don't take a shortcut and try to figure it out without doing the truth table. All right, that is it for today. Thank you.